if and switch statements in Verilog. Kita ra? Naani siya sa behavioral modeling nga concept sa. So quite familiar with the if behavior and the switch behavior in other programming language. Verilog also has an available if-else statements and switch statements. So the syntax that is followed in Verilog for the if-else statement would be the following. If and then your condition and then your sequential statement and then else and then also the sequential statement under the else. So we also take note that similar in other programming languages, the else statement is optional. Then if you have more than two conditions, then you can also use the else if statement. So the syntax also for the else if statement is available in here. We also take note that when we have multiple statements in Verilog, we use a begin and end statement to signal or to identify which parts of the if statements belong to the if statement. But by practice, I would recommend that you use a begin and end statement inside the sequential statements of the if and the else statements. So an example in here would be this one. So this is an example of behavioral modeling mo good kay nagamit na siya og flip-flops. But we'll just try to look into the syntax. Mao na atong gamiton karon na ang syntax. So if we try to look into if and then a reset, so meaning if the reset is true, so it will try to have the begin and end. So begin and end. And then if the reset in here is true, it performs the statement inside the if kanang nasulod sa begin or end. Otherwise, if this is false, ningon siya else. Else and then begin, yan na po end. So kani nga begin ang iyang pares kani. And then there's also a nested condition in here. Sorry, kani di ay siya ang pares ani sa nga else statement. Kay kani adto ni sa begin na always at. So there is a nested condition in here. So if the address ana siya sa ang buhaton begin end. So yung ana ra ang syntax sa if dinhi sa Verilog. Also take note that there is what we call an always at statement sa. An always at statement is invoked when you want that the Verilog compiler will be performing a certain set of operation if there are changes on certain variables. Like for this case, always at positive edge of the clock. Meaning, okay, so meaning every time na makasugat na siya sa positive edge sa clock, padung saka nga clock, iyan ning i-perform sa iyan ning i-check ang condition sa if statement. And then also, na-check kama sa post edge of reset, meaning kung makasugat siya padung saka nga clock or padung saka nga reset, iyan ang ipang-check ang condition, mao gamit anang always at. So every time there are changes on the variables inside the always at statement, ang statements under the always at will be checked or performed. Sa nga na ang behavior sa always at. So take note, kani si always at is used in behavioral modeling but can be used in side by side with conditional statements, if and switch statements. So again, that is the syntax of the if statement. So you can also have like this set of instructions. So if and then condition 1, if this is true, it performs begin and then a set of statements and end. So meaning these two are under the if statement. So if the condition in here is false, then it checks else if condition number 2, begin o end gihapon sa. So meaning these statements fall in the else if statement number 2. So if this is false, again it checks the else if statement condition number 3, begin and end. And then if no conditions are true, it performs the else statement. So na po siya begin o end. Any questions with the syntax of if-else statement? Wala. You can also use compound conditional statements. Like, ang kanang conditions diri, imong i-compound ay and or naapoy or. Okay? Happy? Nakuha?
Kuha na, sir.
Sige. For the next statement, we have the switch statement in Verilog. So, dili siya switch case ang iyang equivalent sa Verilog. But it performs the same functionality in Verilog. So, maingon ta dire case and then the variable that we try to check. Parehara na siya switch. So, switch, nya dayon katong variable nga itong i-switch. And then, after the case variable statement, actual value na dayon. Kaysa hinumdum mo sa switch, naman tayo case 1, case 2, case 3, and so on. There is a Verilog case and then value. If the value of the variable is equal to value 1, then it checks the or it performs the statement under the begin-end statement of value 1. So if not, then it checks on value 2. So if correct or if this is true, yan na po nang i-perform. Lastly, you can add in a default statement. If no case values are equal, then it performs the default statement. Copy? Also, the pair for the case is end case. Okay? So, ang katong sa if, sa nga naman siya. So, dinhi, ang iyang pair, end case. Nasabtan? So, example, this one, so again, this is a multiplexer. So, it checks the value of address. If address is equal to 00, that's a 2-bit nga 00, then Q is equal to A. If address in here is equivalent to 01, then it performs the statement in here. If address, 2 ni siya dapat hanggang 3 man siya. If address is equivalent to 10, and lastly, sa possible values are 00, 01, 10, and 11, parehara na siya if the address is equivalent to 11 or default kana siya sa Q is equal to D. Also take note in here that the always at statement yan ay asterisk meaning a wildcard. Meaning in a wildcard, any change of all the variables, this will be checked and always at. So, iya dyan na i-perform if na ay mga changes. So going back to our previous example, for our ALU, mo man itong ALU ng example and then we implemented it in here. So utilizing the conditional operator. So we can implement this one using an if-else statement or using a case statement. So might be sa yun katong if sa kaning case na lang akong buhato na. So let me try to save this one as okay. Save as 1-bit ALU. This is version 2. V2 dot saan na siya? Relag na file naman diyan na. So v2.v. So what are the things that I'll be changing? So I'll be changing the operation in here. For all the rest, no changes. So what I'll be doing in here is that I'll try to create. So take note that I'll try to create, in here the R is set as an output. So we will try to say always at any changes on the variable, on all the variables, mingon ta always at, and then inside the always at, we use a case statement. The variable that we would try to switch would be the value of the selection input S. Thus, we will try to case the value of S. Possible values of S, that would be a 2-bit 00, and then you can have the begin and end statement sa end. By practice, mo dun na itong buhato na. So what we'll be doing in here is like this. So we would say R is this type of operator So meaning, we will try to assign the values of the expression sa man to addition to sa addition, subtraction, and. So we say x plus y. Although wala pa po ni nato ma-discuss, but we will be discussing it in the next topic. So what is the difference between this one and katong usara ka equal symbol? And then you can copy and paste right away. So copy, paste. So this one now this is for the addition sa. So again, this is for the addition. And this one is for the subtraction. So we would say if S is equivalent to 0, 1, then we would say X minus Y. By the way, this operator is also available in the slides. Pero ato lang giskip. And then we have another case value, 1, 0. So this is for the AND operation, bitwise AND. Bitwise AND. So this is now equivalent to X and Y. And lastly, bitwise OR. So we would say X or Y. So again, this is bitwise OR. And then take note that after the case, we will say end case. End case. Okay? So any questions with the syntax for the switch or the case statement? So man, masayon ni siya compared atong conditional operator.
Yes, sir.
Masayon ni sa. You can also use the if statement. Sige. So padayon ta ha. Save and then let's try to go to we go into CPE. Here, ayep. So I very log minus O, 1 bit ALU B2. That sorry. So OBA 2 output. R is okay. In these types of error, we just need to declare a register for R. Nga na magud siya basta ing aning operation we need a register for R. Okay. Where's my Okay, now it's good. So we now try to DVP OBA 2. Then after which we say DTK wave 1 bit ALU. Overwritan ang atong 1 bit ALU nga BCD. Wala din ako nakuan. Ilisan tong output file name. So that is, let's check. We have the X, we have the Y, we have the S, R. So let's try to check on the output. Nay mo join. Naka-join nun. So in here, this is selection input 00. That is addition sa 0 plus 1, 1. This one is subtraction. Addition gihapon. Sa kay selection input is 00. So 1 plus 1 is 1, 0. Next one is, this is now subtraction. Subtraction na ni. Okay, subtraction. So this is 0, 1. So 1 minus 1, 0. And then in here, 1 minus 0 is 1. Okay. And then you have the bitwise and 1, 0 sa. So 0 and 1 is 0. And then also bitwise and 1 and 1 is 1. For or, 0 or 0 is, nga naman yung 1 man.
Ano mo na ilisan, sir?
1 ay lisan di ay. Asa na aman? Kani. Dapat di ay ani 1, 1. Mara to. Sige. Katora de uspon. So let me try to wala day may listen. Okay, should make this one as B2. Okay. And then B2. Okay, so or 0 is 0. O, sakto na. 0 or 1 is 1. Okay? So that is an example on how to use the switch statement or the case statement. So you can also implement this one with if. Di na lang na ako implement kay sayon kaayo na inig-implement niya sa if. Pariyaran na siya if, then katong 2-bit value sa S. If S is equal to 2-bit value 00, ana sa? Sige. Any questions for now? Wala na? So next week is the midterm examination. So expect that we will be having also an exam next week. Okay? So, pas-pas lang ta karon ha. Dali ra ta mahuman karon. Kato ra may atong topic. So after the gate level modeling, we'll now go also to we'll go back we will proceed to behavioral modeling, the next modeling. So the behavioral modeling is for sequential circuits na katong mogamit na og latches of flip-flops. So which was the last part of our discussion in logic circuits. So in here we will try to continue the concepts in logic circuits of behavioral modeling kay murag wala man ta natiwas ato chapter 6 ra ta kutob. So we'll continue with the rest of the concepts in chapters 7, 8, and 9 in behavioral modeling. Okay? So let me stop my presentation. Okay, stop presentation. And then kindly turn on cam for today so that we can do a photo op